The planet is dying, and it's our fault. I'm Sam Movrum, and I'm a biology major at Iowa State University.
I'm Sam Grinstead, and I'm a natural resources major at Iowa State University.
As a species, great advancements have been made in the technological developments of the last 200 years, but in the process, we've exploited lots of the natural resources. As far as we're aware, we're the only species to know with certainty that the planet is dying. As a species, we're also very aware as to why this is happening. It's us.
Despite having identified several ways in which we are contributing to the rapid advancement of irreversible climate change, we consciously don't do nearly enough to mitigate the destruction we create.
We are smart enough to know the planet is dying.
We are smart enough to know we're the most significant cause.
And we are smart enough to know several ways in which we could be helping.
With the power of being intelligent enough to exploit Earth's resources and be cognizant of our actions, shouldn't we assume the responsibility of ensuring we do all that's possible to preserve Earth's biological potential and natural beauty?
An example of this selective ignorance is the meat industry.
Information about its role in environmental destruction has been publicly available for decades. Yet there's a pervasive attitude among Americans that these environmental accusations aren't serious, and it's common for the average American to avoid information of the sort.
We've made great advancements to systemize the industry. It's still a growing, booming industry, it's still multi-billion-dollar, and as a result, the land is stripped to plant crops for the huge amount of animals.
As the land is stripped, it's further and further deprived of nutrients.
As the industry grows, monoculture prevails.
As monoculture prevails, soil health deteriorates, and crop systems require more and more external sources of irrigation.
Essentially, we're left with a system that requires lots of water, produces lots of methane, continuously strips the land of the nutrients, and creates huge dead zones in our oceans.
We know these things. They are proven time and time again to be unsustainable. Why does so much of the general public not seem to receive this information that is so scary to us? Why is there no change? It is extremely important that you understand this. We are not out to demonize anyone, be that the farmer, the consumer, or big agribusiness. We are simply here to give you the scientific facts about the subject. We are not cherry-picking facts to re-solidify our own opinions.
This being said, we will not sugarcoat this issue to make people feel better about what they are doing. Your actions have real consequences, regardless of however the science is morphed or downplayed by unreliable sources or cherry-picked to create a falsely justified sense of security.
All right, guys. I want to use this statistic as an example of why you need to check your sources. All of the information in the statistic is true, but the facts are cherry-picked and are misrepresentative of the real problem. This is the risk you run when you collect your information from partisan sources like sacredcow.info instead of reputable government-regulated information databases. This statistic is a commonly used argument advocating for the belief that livestock do not contribute a significant amount of greenhouse gas to our planet.
Unfortunately, this metric is not even remotely useful when assessing the damage of different greenhouse gases. If you go on the EPA website, you will find out there are different ways in which we measure greenhouse gas damage. One, the statistic shown, is the abundance or concentration metric. This shows what percent of the total greenhouse gases are which gas. This does not, however, explain the proportional effects of each greenhouse gas. There is a metric for this called global warming potential, or GWP.
This GWP measures the proportional effect of each gas in the atmosphere and is measured in specified units. The global warming potential, or GWP, of CO2 is the baseline measurement unit and has a score of 1. The GWP of methane, or CH4, is 28 to 36. This GWP score takes into account the shorter lifespan of CH4 and also the potential of CH4 to create new greenhouse gases such as ozone. So, if you weigh any of these gases based on their potential for warming the planet rather than the physical space they take up, the statistic looks a lot different. Comparing the amounts of carbon dioxide to the amounts of methane is simply apples to oranges. Comparing the two as equals is greatly misleading and inappropriate.
If we convert the chart's values into their actual GWP values that properly weigh their destruction potential, we see a very different picture. The EPA estimates the GWP of methane to be a factor of 28 to 36. Conservatively, we will use the lower end of this factor. Using the pie chart, let's assume this is out of 100. Essentially, we are removing the percent symbols to give us numbers we can factor. Carbon dioxide has a GWP of 1, so 82 times 1 gives us carbon dioxide's weighted value, 82. Methane is only produced at an eighth of the rate of carbon dioxide, but its factor is much more significant. 10 times 28 gives us methane's weighted value, 280.
According to a 2019 EPA study, cows and manure management contribute 36.1% of methane emissions. The weighted methane value, 280 times 36.1, shows us that cows alone contribute 101 out of methane's total weighted value of 280. Remember that the total carbon dioxide weighted value was 82.
If you adjust the GWP for these statistics, methane warming potential simply blows CO2 out of the water and steers our planet toward destruction.
Even if you can live with the fact that these gases are warming the planet, it's not even brushing the surface of how much water and land go into producing cattle. Speaking of apples to oranges, according to National Geographic, one apple requires 18 gallons of water, while one orange requires 13 gallons of water. 1/3 pound burger requires a startling 660 gallons of water to produce, including feed irrigation, water for drinking, and meat processing. According to a University of Nebraska-Lincoln study, a single cow requires 3.45 acres of land to be fed with hay. This is over 2.5 football fields of land per cow. Now, think about how many cows there are. Roughly 1.5 billion. No matter how you look at it, our current system is environmentally unsustainable. It's time we take the bull by the horns and look at all the possible solutions.
The consumption of insects, which is known as entomophagy, is common among over a quarter of the human population around the globe. Using insects as a source of protein and energy has been part of human nature for thousands of years. Today, this generally happens in poorer countries that can't afford to eat a lot of meat protein. With modern concerns about the environmental issues of the meat industry, insect protein is becoming a promising, more sustainable alternative.
The need for protein is expected to increase by nearly 75% in the next 30 years due to our ever-increasing population. Using insects to supplement this need for protein is not only a viable option, but an environmentally favorable option as well. Using insects for consumption is a better alternative to beef because they are easier to contain, cheaper to raise, and use less resources than do livestock.
The animals we eat are usually large and require a lot of space to be able to get enough meat out of them to be viable. It takes about 2.5 acres or about 2.6 football fields to feed a cow grass throughout its life. If these cattle are an average of 2,000 pounds each, it would take approximately 550,000 crickets at 0.6 grams each to equal their weight raised on land and resources, not even close to what it would be to manage just one cow-calf pair.
Crickets are easier to manage too. These crickets won't go knocking down any fences or hurting each other. They can be kept confined to small areas without taking up space that can be utilized for other important practices.
The rate of gain for insects is also much greater than that of your average grass-fed beef cow. For example, a beef cow fed on grass could need as much as 25 pounds of forage a day to gain enough weight to be able to harvest in the short time frame provided. This is 2 to 3 pounds of gain per day on just grass, or about an 8-to-1 ratio.
Alternatively, crickets only require 2 pounds of feed per pound of gain. 2 to 1. Wow! They are also about 60% protein by weight, meaning that in 100 grams of cricket, you can receive 60 grams of protein, whereas in most cuts of beef, the same 100 grams only contains about 25 grams of protein. These numbers speak for themselves and show the greatly reduced cost of producing the pounds of protein needed to match beef production. This also opens up the possibility of using our farmlands that were once used to raise feed to raise other needed commodities.
Crickets, on average, require the production of 2 kilograms of greenhouse gas per 1 kilogram of food. This is a ratio of 2 to 1. Cows, conversely, have a ratio of about 20 to 1. Because of crickets' smaller size and higher proportions of digestible materials in their bodies, they are a much more efficient source of nutrients. This trend holds true across almost all insect proteins.
Production of protein from animal sources is an uneconomical use of land and natural resources. Crickets and other insect protein sources are more economical, consume fewer resources, and produce less greenhouse gases than all livestock. Raising insects as an alternative protein source could be the key to revolutionizing agriculture. The only issue, people don't want to eat bugs. As the problem continues to get worse, it will be increasingly important to move past the cultural stigma against insects that is pervasive in Western countries. So we all know that there are a lot of existing traditional alternative protein sources that we're currently exploring. But with a recent breakthrough discovery, scientists have delivered us another way in which we can obtain protein that will have reduced environmental costs.
You may have heard of the most recent companies that have emerged as the leaders in this new industry, Impossible Foods and Beyond Meat. These companies are the two leading producers of cultured meat, or essentially lab-grown meat. Cultured meat is ultimately a plant-based meat product that is produced in vitro using tissue engineering techniques. Scientists use genetic engineering methods to produce a patty that both looks and tastes like a traditional burger, but comes with less risks to our environment.
This is a relatively new development. It has only recently begun to be produced on a large scale that reaches outside the laboratory. Therefore, there's still room for improvement as to how to minimize the environmental costs and maximize efficiency. However, there have been a few studies that have taken a closer look at cultured meat, and the results are promising.
These studies use a method called life cycle assessment, or LCA, for their studies. Science Direct defines this method as a holistic, cradle-to-grave analysis that assesses the environmental costs at every stage of a single product's life. This can include raw material extraction, material processing, manufacturing, distribution, and actual use.
One 2018 report from the Center for Sustainable Systems at University of Michigan confirms the beliefs that we can find a more environmentally friendly alternative protein source in cultured meat. With the LCA method, the research team looked at the production of a 4-ounce Beyond Meat patty as well as a comparable beef patty and measured their overall greenhouse gas emissions, cumulative energy demands, land use, and consumptive water use. Here are the results of their findings.
The researchers found that the Beyond Burger requires 99% less consumptive water use, uses 93% less characterized land, produces 90% less greenhouse gas emissions, and demands 46% less non-renewable energy use. All across the board, the Beyond Burger beat out the competition and highlighted its ability to be an environmentally friendly alternative protein source.
The other study that utilized the life cycle assessment methodology to analyze the environmental costs of cultured meat production found similar results. The results of these two studies produced comparable results. And the results confirm the idea that choosing to order a Beyond Meat burger or an Impossible Food sandwich instead of a traditional burger, when available, will help us make strides towards saving the environment from a climate crisis.
We have explained the problems with the meat industry, ranging from production of greenhouse gases to excessive land and water expenditure. Please remember this information next time you're buying a steak or eating a burger.
Our goal is not to convert you to a vegan or a vegetarian, but more to make you aware of the effects that you as a consumer have on the planet and to persuade you to substitute some of your meat intake with alternative sources of protein. With knowledge comes responsibility. While it is fun to be blissfully ignorant to the effects we have on the world around us, now that you know the impact you have, it is your ethical responsibility to move the needle of change in order to preserve our dying planet.
Although the science on this issue is pretty clean-cut, there is a pervasive ignorance and indifference about this issue. As citizens in a society privileged with the ability to receive education, we must not squander what we are given and ruin the world for our own short-term gain. In order to make these solutions cheaper and more accessible, we must create a demand and a mainstream culture of consuming them.
We encourage you to go out and try an Impossible Burger, cricket chips, or simply eat more ethically. We think you will find there are plenty of delicious foods to be eaten just outside of your comfort zone.
The planet is dying, and it's our fault. But with the proper knowledge and ethical discipline, we can begin to fix it.